Hello, Mr. Eric, Mr. Ryan, are you alright?
Yeah.
Okay, so I have a list of numbers. Yeah, I have a list of numbers like 3, 2, 1, 10, 20. And I want you to pick two numbers. If look k numbers, k equals 2. I want you to pick k numbers. And then the difference. I want you to find out the minimum difference between the highest and the lowest of these two numbers. Am I clear with this problem? So first of all, pick two numbers, yeah, from these. How many ways can you pick two numbers if you're going to brute force it, yeah? If we want to brute force this problem, then we need to pick two numbers out of, for example, this is n numbers, yeah? N numbers.
Does it have to be in order?
Good question. Does not have to be, yeah. Good question, you know?
But what if it is in order?
So what difference does it make? We want to pick two k numbers, right? We want to pick k numbers out of it, and we want to find out the maximum, and minus minimum of these k numbers. Yeah, k numbers. Let's do
It'd
it.
be easier if we sort it.
Good question. Okay.
That's not a question.
Okay, good solution. Maybe good guess. So look, we want to pick k.
Go.
Okay, so look, we want to pick k numbers, and then they make a. And we want to find out, okay, so when we pick the k numbers, we know the maximum, the highest, and the lowest, of that array. Right?
Yeah.
Let's say this is the difference, and we want to minimize the difference. Okay? We want to minimize the difference. So what's your approach? You mentioned, yeah? So look, first of all, we can talk about the brute forcing. How can we brute force? There are n numbers. And we want to pick two numbers. How many ways of doing that? Remember the POC? We use the POC?
Yeah.
P or C? Which one? Pick k numbers out of n. Is it P or C? What's P? What's C? Remember?
I think it's C.
Yeah, we're done. What's P? Permutation. And what's C? Combination, right? So combination does not have order. Use the C. P has an order, right? Combination means that look, if I want to pick n numbers out of k, right?
CP.
And then what? And then what? This is the complexity. We pick these C and k numbers out of n, and then we want to find out the maximum and the minimum of those k numbers. So that's O n times n, right? Times k, because they're k numbers, right? So the complexity will be this: O C n k times k. What's C n k? C n k is picking k numbers out of n, and it would be equals what? N factorial divided by k factorial and n minus k factorial. Okay, so that's the formula to calculate it. You don't need to remember, but you have to know that it's quite complicated. If this, yeah. See, picking one apple out of 3. How many ways of doing that? Picking one apple out of 3 apples.
3.
Picking 2 apples out of 3 apples. How many ways?
3.
Yeah, well done. Look, so you remember this, yeah? CNN equals CNN minus n, yeah? Because every time you pick one apple, you also have a way of picking 2 apples, right? Because look, every time you separate one apple and there are solutions for 2 apples. Do you understand? Yeah? Got it? Can I ask you to sit there, please? Okay, now so the solution is this. Can we do better? You mentioned about sorting, yeah? How do you come up with this clever solution, huh? If we saw this original number.
You can just look the first thing and then just look below.
Yeah. So if we saw the numbers. So if we saw this number, what's the order? 1, 2, 3, 10, 20. If we by the way, if we saw the numbers, what's the term complexity if there are n numbers?
Log n.
We're done. Okay, O n log n. We can use the quick sort, merge sort, you know, yeah. Those solutions are O n log n. But if we go for bubble sorting, yeah, simple sorting, that will be O n squared, right? But usually it's O n log n, yeah. So look this number, and we want to pick two numbers. Pick two numbers, so we can go through this, yeah, yeah. What's the difference between these two numbers? The highest and the lowest.
Choose the
One.
highest.
What's this?
1,
1.
7,
8, 7.
10,
I can't do
Okay,
it.
what's the minimum?
1.
1, yeah, that's it. Yeah, got it? Why this solution is working? Why? Because why? Can you imagine if we saw these numbers and we pick the lowest and the highest, we want to minimize it, right? So if we want to minimize it, we want to, this number to
I
be.
thought 20 is the highest.
Yeah, but I want to find the distance, the shortest, the minimum, the maximum and minimum, maximum and minimum of k numbers. So if we pick 10 and 20, the maximum is 20 and the minimum is 10. The difference is 10, right?
Yeah.
So if we pick 20 and we pick 1, what's the difference?
19.
19. You see the difference? So why this solution is working? Because we want to make sure these k numbers stay as close as possible. So how do we make sure those numbers stay as close as possible? We sort it, right? If we sort it, right? This number, look, if we pick 2 numbers, if we pick 3 numbers, what's the shortest distance? 1, the shortest distance is here, right? Yeah? Because look, 10 minus 1 is always bigger than 3 minus 1. Because after sorting, these numbers stay close to each other, right? So look, if we saw this original array, we use O n log n, right? And then we pick k numbers. So we just need to try the pairs, right? The highest, right? We divide this sorted array into groups of k. So like that, like that, like that, and we just try the brightmost, the highest, the maximum, and the minimum. We calculate the difference, and we keep doing that. We update the minimum, right? Okay, that's it. So let's write the code. If you can, today's code is quite simple. If you can implement it, it will be just 2 lines. 2 lines, yeah?
So it has
Define
the find and the return.
Mean
That's what
k,
it has.
mean k different, yeah? Different. Like let's say numbers, and then k, right?
I think it's supposed to be sort and then return.
Okay, so which one? The first one, we need to sort the numbers. The nums dot what?
Sort.
Yeah, well done. That's
It's
it.
gonna be 3 lines.
Not including this line, okay? This is the function definition. That's the implementation. Now we want to find out. Look, after this is the number, yeah? 1, 2, 3, 10, 20, okay?
So return.
So this is nums, yeah? Now this is the nums. So we want to find out each group of the difference. So what? Return minimum, yeah? Minimum what? Nums.
I.
So if we start with these nums, so this is I, and what's this number? What's this number? What's this? I plus k
Squat.
minus 1, right?
Yeah.
Yeah? Got it?
Yeah.
So look, nums I plus k minus 1 minus nums what? Nums what?
No lie.
I. Okay, so now for I in range, the whole thing is length n, yeah? Length nums. Minus k, so this I will be up to this point, right? So k is what? 1, 2, nums, length k is 1, 2, 3, 4, 5. And we want to get this point. The last index it will be 0, 1, 2, 3. 3, yeah? So what? 5 minus 2, minus k. Is it minus k? Minus k plus 1, plus 1. We need to have plus 1, right? Why do we need to plus 1 here? Length numbers is 5. 5 minus k is 2. Plus 1. Right? Up to this point, because up to range, right? So this will be 4. So range up to 4. So the last index will be 3. 0, 1, 2, 3. Okay. Got it? That's it. So basically, look. Mean nums I plus k minus 1 is this point. Minus nums I is this one. For I in range, for this I in range from 0 to 4, this is length nums minus k plus 1, but not including, right? Remember this range function, yeah? Range 10. What does range 10 give us? 0, 1, 2, 3, up to 9. It doesn't include the 10, right? That's why we plus 1. It doesn't include the plus 1.
Doesn't
Okay? Another way, look, another way is we can use this k here. So it will be nums I, right? Nums I. Let's say nums I is here, and then nums I minus k, right? Minus k. So I is 1. 1 minus k. We need to minus k plus 1, right? Because nums k plus 1. Nums k plus 1. And then for I in range k minus 1 up to length num. Right? Because the first index will be 0, 1. Right? If this is k, right? And this will go to the end, and then you look for the k I minus k plus 1. Does it make sense? Yeah? Okay? So can you explain to me what's the approach? What's this approach?
So technically,
First of all, we need to
sort it and then you just put the nums up.
Yeah, we need to check the every
Oh,
group of the k.
up to the
Yeah. Because we are looking for the minimum of this maximum
then,
this k array, right? K array minus min k array, right? If we sort it, the maximum of this k array will be the rightmost, yeah? Will be on the right hand side, am I right? Yeah? And then the minimum will be on the left hand side. Why is that? Because this array is already sorted, right? If k is equals 3, for example, if k equals 3, Ryan, listen. If k equals 3, 2, 3, 10, what's the maximum? Okay. What's the maximum?
10.
What's the minimum?
2.
You see, very easy, yeah? Because always the maximum of this subarray is always on the rightmost, right? Got it? And the minimum is on the leftmost. I can even, if this is I, the index I, and then this index will be I minus k plus 1, yeah? Easy, right? That's why we sort this array. Because once we sort it, we can find the maximum and the minimum in constant time, just by looking at the index, right? Because it's always sorted. Am I right? Yeah? And then we just need to check what? I times, right? And times for the k times for the subarray, right? How many? So what's the, yeah, k times. No, is this k times? No, it's the length n minus k times, yeah? Yeah, n minus k times, roughly, or k minus 1. Okay. So this is O n log n, and this is O n minus 1. What's the time complexity overall? Which one is more time consuming? This one or this one? Which step? This algorithm consists of 2 steps. First of all, sorting O n log n. The second time is O linear, yeah, because we're just scanning the array, yeah.
Sort.
This is more time consuming. We're done. So this is dominating. So
Yeah, I said.
so what's the time complexity for overall this approach?
Not again. Oh, look.
O n log n. Okay, that's it for today. Good job.
Bye.
Bye bye.
Wow.
Bye bye. Bye bye. See you later.
Bye.
Bye bye.